Okay, hello Twitch. Well, Carl the data scientist here, and I guess it's better late than never. I'm just gonna start out by apologizing. I've just had a horrible last hour wrestling with my live streaming software. Just before I was about to go live, Streamlabs OBS somehow forgot all my settings, my layout, and everything. And I pretty much had to spend the time just like getting my layout back together. If you're a streamer, you'll know what I'm talking about. You got all your settings and things set up, but Streamlabs can be a quite cantankerous piece of software. But anyway, let me shut up. I'll stop bitching. But if I'm a little bit, if I'm a little bit, put off, it's because I just had that difficult experience going live. But first, let me back up and introduce myself. Again, my name is Carl. I'm a data scientist in the Bay Area. It's been a while since I streamed, to be honest. And the truth is, I've just been busy at a startup where I now work. It's a company called OfferFit. So if you know my history, I started streaming as like a hobby and a way to promote my book during lockdown. Back then, I worked at a company called Zora as the chief data scientist. And I had a reasonably good work-life balance because the company had gone public at that point. So when I was streaming, I had a lot of time. But then eventually, naturally, I left that company, moved on to something new. My next startup was a company called Migo, and that was in early 21. I guess my workload wasn't too bad then for a while, and then I got promoted, and then my work-life balance went out of whack there, and my streaming fell off kind of in late 21, early 22. Then, to fast forward, July 22, I left Migo, started at my current company called OfferFit, and honestly, that's when my work-life balance really fell over. So it's just taken me a while to get some new content prepared for streaming video, since my main focus has been my day job at OfferFit, really. So yeah, I guess you could say I'm not like, a superstar live streamer, but I am a real live data science leader who also live streams occasionally, so you can give me credit for that. All right, so enough. Number one, I was bitching about Streamlabs. Number two, I was reminiscing about my past history of streaming and how I haven't been streaming for a while. But I'd better get on with the content right now, or no one will stick around and watch the on-demand video that will be posted. So without further ado, let's get into some real data science. I'm going to start out with a little setup. There we go. GCP, Google Cloud Platform. We're going to do a little setup and quick start demonstration here. Let me get over there. Oh yeah, and like I said, everything is just, I'm a little bit out of it because of my issues with getting my stream set up. So here I am. I'm going to go into Google Cloud. I'm signed into my account, and I think that's actually a little bit big. I made it big so y'all can see it on the stream. I'm going to get right in. The first thing you have to do, well, as I say in my overview here, first thing you do when you go into Google Cloud Project is check your project. For me, I already have a project set up. I called it the Churn Stream project. You will have to have your own project set up to do this. Also, I'll mention that Google Cloud gives you a $300 credit when you sign up, so you could pretty much follow along with everything I'm doing here for free. So let's see. In the Google Cloud, the next thing I was going to do is create a database instance. So I'm actually not on the right tab. I need to go over here and get down to my SQL tab. Let's see. And what am I going to do here? I'm going to create a Postgres database to generate the churn data that we're going to be looking at today. Because in Fighting Churn With Data, it's all written against Postgres, a popular database. So I'm just going to go over here, create instance. I'm going to choose Postgres SQL. I don't even know how to pronounce that. Let's see. I need an instance ID. I guess that's one that I've been using in the past. Although if you look closely, I had a typo. Oh my God, am I going to get grief from Google Cloud too? I had it bad enough from Streamlabs today. So let's see. This is still having some issues. Let's call this Churn Sim Advanced, because this is our new Advanced Churn Simulation stream. My password is usually just churn. So let's see, I'm just going to leave all these settings. I think it's standard. You do have to, actually, as it says in my instructions here, note the region whenever you do this, because you'll need that region later. So I chose the production type. I want my region. I guess I'm going to do something close-ish to where I am. I'm in California, so I'll go with Oregon. And I think that was everything I was supposed to remember. 8 virtual CPUs, 32 gigs memory. I guess those kinds of settings are like in here. Well, that's fine. Anyway, let's get on with it. I'm going to create an instance now. My instance is being created. And this takes a minute. This is the reason why I dropped into, this creating my database instance first. Let's go back to all right, well, I'm going to go on to do the next part of the setup, which is to set up a virtual machine. That's the other piece of cloud infrastructure we need to be setting up here. And this one I have bookmarked to the instances. And hello to everyone in chat. Let's see, Idris Softmax Deep. Could that be Idris from OfferFit? So maybe with a slightly different spelling of your name? I'm not quite sure. A few folks from OfferFit said they might join me here. Okay, so what am I going to do? I am going to create an instance. And Avery, wow, your name I can actually tell. But your names are all getting cut off in the chat that's displayed. And this is what I was talking about Streamlabs screwing everything up. Woo, see, let me see if I can fix this. So all my settings were lost by Streamlabs when I started this morning. And these are the type of settings I'm talking about. Things like the positioning of all of your stuff on the screen. What? Oh, this looks terrible. All right, that was definitely not the right chat setting. All right, I'm really wasting time here, and I super apologize. Again, I blame Streamlabs for all of these troubles, but it is free. Maybe I should have paid, and then it would have worked better. Let's see. I'm basically just trying to find some settings for this chat box, which will let everyone see it. This is never something you should be doing live as a streamer, and I'm only doing this because I think I've got a kind of friendly audience here. And again, I completely blame the streaming software for losing all of my settings right when I was trying to go live. You can't see what I'm doing, but I'm trying to change the chat box so that it is sort of visible. All right, look, I just got to get going. So now we can kind of see see something of people. Yeah, this isn't too bad, right? All right, there, we can see it. Thank you. So let me go back to creating my instance. What was I supposed to do? See, this is a problem getting distracted. I have to check my region here and make sure it's the same as the region on my other, on my database. And here, I think I was gonna do an E2 standard because that's something I've tested before and it worked out okay for me. So let's see, E2, yeah, I guess that's already it. I'm defaulted to E2. Let's see, machine type, okay, and I wanted like 16. Let's see, I guess I gotta go high CPU, and then I can do a high CPU 16 should be good for what I'm doing here. All right, anything else I was supposed to remember? Just the instance type and the region should be good. All right, so now I've got a database that's creating. Maybe it's actually created completely. And let's go back here and see if I'm getting like the green light or yeah. Cool, so these will be good. Okay, the instance is still creating, and while that happens, I'm gonna go back to my talk track. And this is, if you haven't seen my old streams, this is the way I always used to start. By answering a question for some people who don't know, what is churn? So churn is when subscribers, customers, or users quit your service or they unfollow your stream, which some people might be considering after my abysmal launch today. But so churn is bad. It's when people are ditching you. And the origin is from something called the churn rate, which is the percentage of customers that drop out. And churn is also now a verb. You can say the customer churned, or I'm gonna churn from Hulu because I got sick of what they're showing me. Or it's also a noun. You can make a report of last quarter's churns, or even describe a customer as a churn and be like, oh, that customer is a churn, they canceled last week. So that's what churn is if you don't know. And what is Fighting Churn with Data? If you don't know, it's my book that I wrote. It was based on my experiences back when I was chief data scientist at Zora. And it's from a publisher called Manning Publications. Manning always has these old-fashioned people, on their covers. So that's why we have an old-fashioned person on the cover, but I did get someone churning butter. I asked for that. But anyway, so you can get the book from the publisher, and there's also a discount code here for 40% off, Twit Gold 40, that you can use, and then my publisher will know that you watch the stream. But what is Fighting Churn with Data really? It actually really means data-driven churn reduction. And what is data-driven churn reduction? It could be making a product with features and content that customers love and using your data to figure out what they love. It could also be marketing, like targeted engagement campaigns, something we do a lot at OfferFit, my current company. Or it could be customer success and support. And if you're not familiar with it, customer success is like a proactive outreach to your customers to help make sure they're succeeding on your product. And you can use your data to figure out which customers are succeeding or not with your product. And lastly, there's sales and pricing. You might use your churn data to right-size your plans so that customers all get a value without giving out discounts unnecessarily. And we're seeing here some more of the aftermath of my Streamlabs OBS meltdown this morning, which is that you can't really see everything. My video was a little bit too big. All right, now you can see everything. So I'm still, like I said, still recovering from the Streamlabs meltdown this morning, but hey, what are you gonna do? All right, let's move forward and say, oh, okay, more of my backstory or my promo. Why should you learn churn? Well, number one is it's the most common data science problem in the world today. And I say that because every company that's out there has churn. But churn does require some special techniques, which you can learn through this stream series or my book. And it's also a great way to build your data science foundations, because in my book and in the stream, we go from raw data all the way to usable results, which is, definitely a good way to learn something. So that's why you should learn about churn. And now, finally, let's get on to what are we doing today. Today is the Advanced Churn Data Simulation. And if you're familiar with my book, you'll know that there's a churn data simulation in it. And this is a much improved ultimate churn simulation version that we're doing. So very excited. to tell you about it. What we're gonna do is first I'm gonna do a little bit more setup on the Google Cloud front so that we're ready to run the simulation. Then we'll actually run the simulation. And then while it's running, I'll just kind of talk about it, which means you'll learn something about the simulation. I'll present some of the theory behind it and also take a look at some of the code that runs it. And then at the very end, we'll dig in and we'll look at some of the data that was produced by the simulation. And I'm going to guess this is all going to take us about 45 minutes, an hour, something like that. I'll also put out, I'm always happy to take questions from the chat. Also, I take feedback on the sound. All my sound settings were also completely lost in the Streamlabs setup meltdown this morning. So if there's any problem with the sound, please let me know, and I will try to accommodate. All right, so let's go back to setting up in Google Cloud. First, I need to get on my virtual machine and install a bunch of software. And this is basically what you would have to do if you just made a new Google Cloud instance and you wanted to try this yourself. So let's go back, and my instance should be ready. Yep, it's looking ready. So now I'm going to click the SSH button. I'm going to pop up the SSH window. Can you guys hear the music okay? Oh, good. You like it? All right. Well, I'll if you stay till the end, you'll find out what it is. Well, it's actually just stream safe music from Spotify. Let's make this bigger. I'm afraid people on the live stream are not going to be able to see this. All right. Oh, that's too big. All right. So first, I had to do, I think it was sudo apt get, what was it? Install G++, which, as you may know, that's basically just like a compiler. But it doesn't come with a compiler that we're going to need to install everything. So that was my first step. And next, okay, I need to get the Python 3 venv installed. This does take a minute though, which is why we need the music, because sometimes, you know, we're just waiting for things. I'm sure most programmers out there agree that music is an essential part of our toolkit. All right, so there's G++. Then it was Python 3, what is it? -vm is our next install. This one's a little quicker. I think G++ is the slowest, actually. And next, I need my PostgreSQL client. Let's see, we'll just go up. PostgreSQL client. And next we will need, oh, actually that's all the installs. The next thing I'm going to do is actually create my virtual environment. Please, it is possible to have the rediff. Actually, I'm not quite sure what you mean, Idris. Python 3 -m venv, and that's actually the module that I'm running, and then the second VM is just telling it that my virtual environment is going to be named VM. So the first thing here, this is the module that I'm running, and the second one is my very uninspired name for my virtual environment. Is just, I called it virtual environment venv. All right, okay, also I need to make a directory, as will you, so I will make a directory churn output, and that's where some of the program outputs will go later. And next, okay, now I'm going to activate my virtual environment. VM bin activate. I'm sure most of you have done that about 10,000 times in your life, and if not, this is a good trick to know. Python, use a virtual environment. And finally, I'm going to install the fightchurn package, which is my own package. Through many struggles documented on my old live streams, you can see me struggling to figure out how to package my code. Let's see, here it goes. All right, now that's gonna run, and that will take a couple of minutes to finish. So I'm gonna go on to my next part of my setup here. And this is to set up a connection between the database and the virtual machine. So I need to get the virtual machine address and then add it to the database instance. So let's go back to, now I actually need to go back to here. Let's just get this out of the way. I need to basically get, I think it's this external IP is what I need. So I copied it there. Now I need to go back to my SQL instance, get in here, and there's a, let's see, connections. I need to go to connections. Go to connections, there we go. And I think, let's see. Okay, where's the add net? Oh, maybe on the networking tab, add network. Yeah, there we go. Add network. And this is going to be my churn sim instance. You can give it any name you want. And then this is going to be my public IP address. And the one thing, a gotcha I've made here before is after you've left your add network screen, don't forget to save. I have definitely made that mistake before, and it definitely does not save without it. Oh, a replay. Yes, okay, so you mean a replay. Well, there will always be replays of this. I leave all my videos up basically forever. You can watch a video, the replay of my first video from like 2020 or something, if you dig around in the bowels of my my Twitch channel. All right, so I did the add network, I did the save button. Okay, I should be good now. The next thing I have to do is create my database. Well, first I have to connect to my database. And oh boy, this is getting kind of annoying. Hold on, let me go back. I'm actually just gonna cheat and kind of copy paste this out. But I'm sure you understand. Let's see. All right, so now I'm pSQL. So actually here first we can just quickly review that my package install seems to have worked out, no errors. A whole bunch of packages were installed. So next I needed to do this pSQL command, and what I'm missing here is the host address from my database. So let's go back here, and I guess I would get that on my overview. That would be this public IP. And let's see. All right, so here goes nothing. If I did everything right, this will give me a connection. All right, I seem to be connected. That's good. And the thing I have to do is actually create the database. I could never find a way to script the creation of a database in Postgres. So this is one little manual step you have to do. But it also shows me that my database connection is working. So this is actually kind of good. Now I just get out of here, and wow, I think we're practically ready to run the simulation now. All right, yeah, that's the end of the setup. The next step will be actually running the simulation. So these are the commands that I'm going to run once I'm in Python. I think I'm actually missing a key step there though, which is first run Python. So this will be importing my fight churn package. Actually, I didn't really need to do that. What I need to do is from fight churn import run churn listing. Is kind of the main module that lets you do stuff. All right, now I'm actually going to go back to copying out of my slide deck because this stuff is just, you know how it is typing code. Whoops. That copy paste did not work. So much for copy pasting. Okay, why don't I try doing it by typing then? Run churn listing, and you have to do a little environment setup here. So churn is the name of my database, or my schema, I think. Postgres, is the default user I'm logging in with. Churn was my password, very secure password, I know. But remember, we're only storing simulated data here. Okay, now I need to tell the churn program, the churn package, where my output is supposed to go. Whoops, home user churn output. Oh yeah, I just made it in the user home directory. And lastly, I need to do that host command, which if I scroll up, didn't I just use that? Or I guess I can just get it back from my other window here. It's just this one. Whoops. That was back on the slides. Here I am. This is going to be setting up my churn environment. Permission denied on home user. Okay, so now I'm doing something probably stupid. Let me double check. Home user churn output. Why is that not my directory? Why do I not have permission on it? All right, definitely not liking that. So I'm gonna get out of here for a second and just check. Oh, it's home Carl. Oh yeah, I was supposed to replace user with my actual user. It's not like a default. Or what I mean is Google Cloud has taken my name and made it the user. Gotcha. All right, going back into Python, and we can just replay a few of those commands. And now this should have been home Carl churn output. All right, so that seems happy. All right, we are finally at the grand moment, the big moment where I'm gonna run the churn simulation. And if you're familiar with this from my book, this is the first part where we're really changing it up, because we're gonna run a different simulation. And I'm also going to be lazy and try to copy this command out, although as you saw, it didn't go so well for me last time. This time it seems to have worked. The program has launched. Let's just look at that command again real quick. The difference from the original churn simulation in the book is, number one, I'm saying the schema here is CRM5. Also, there's a new parallelism setting that you can use in the churn simulation, which wasn't in the original book. And this will speed things up a lot, obviously, 16x. So it creates some tables in our database. And then this is actually a printout of the YAML configuration for the simulation. And we're going to spend more time looking at that later. Right now, it's telling me to enter the name of the schema to make sure I want to proceed. And that should be the start of it. So yeah, so the simulation is now running. One last thing I'll do, kind of just for kicks, is we can open up another SSH terminal by going back here. And whenever I'm doing something with like parallelism, I usually like to just take a look and, look at the computer running. Now I'm back on the instance in another window, and I'm just gonna hit the top command and see that actually, yes, I do have a whole bunch of processes running, eating up that CPU. And lastly, maybe I'll check out back on my, here, we might actually see some activity in a few minutes. Let's see. I make this like 1 hour. Well, okay, so it's not showing much activity yet, but maybe in a few minutes we'll see it spike up from the work that it's doing. But anyway, so this is the simulation. It's doing 2,000 initial customers for the simulated month of January 2022. And yeah, we're just gonna let that run. So basically, I'm gonna move back to the talk track on the slide deck. And there is my simulation running. So that crosses off part 1 and part 2, setting up in Google Cloud, running a simulation. But you know what? Maybe actually I'm going to reduce this a little bit. So just so we can see in the background, that the simulation is still running. While I now go into the next phase, which is just talking about the simulation and telling y'all what it's actually doing. So the first thing I will tell you is what's so advanced about the advanced simulation? Well, if you know the simulation in Fighting Churn with Data, it's actually really simple and it's not very realistic. I mean, it has a lot of realistic elements, but there's only like 8 different user events, and it was a social network, kind of a dumbed down social network simulation is what a lot of techniques in the book were taught in. And it was so simple, I couldn't even teach all the techniques in the book. If you read the book, there's some parts where I'm like, oh, you should use this code to analyze the data, but don't bother, on the simulated data because it's just not that good, or you can't really see the effect of this code. But with the advanced simulation, it's realistic and you can actually test all the code from the book and get meaningful and interesting and realistic looking results. So some of these things there are 5 product plans and prices with different usage limits for each plan, as compared to the book simulation, which had none of that. There are 25 types of user action events, which is better than the 8 types in the book, although those of you who are professional data scientists and machine learning engineers will actually recognize that 25 types of user events is actually not that many. Usually you've got like 50 or 100 or, a couple of hundred or something. But the truth is I went with fewer just because, I don't want to make this simulation take too long to run or take up too much space on your hard drive when you run it. So I'm doing you all a favor by having 25 instead of 100. It makes it realistic without wasting, time and space. Also, there can be up to 100 users per customer account. If you recall the original Fighting Churn with Data book, it was only single user accounts, so you couldn't do any analysis of users on the accounts. There's also choices for the account billing, meaning monthly, semi-annual, annual, stuff like that. And again, in the book, I talk about analyzing the billing frequency, but you can't do it. Now you can. There are 2 add-on plans, so that just throws in an extra, monkey wrench into your analysis and your data. And also there are user actions with dollar values associated with them. There's a whole other set of techniques I talk about in the book where actions may have monetary value or they may have a duration or a time value associated with them, but you could not actually analyze them with the simulated data in the book. So that is the advanced simulation. For people trying to learn data science, this gives you hands-on practice with all of the techniques in Fighting Churn with Data. So it's much more realistic of a challenge to analyze and do the machine learning. And I think this is now really even usable by researchers who want to do machine learning research. This data is very realistic and you can make a lot of other realistic simulations for doing machine learning research. And that's something we'll talk more about later. All right, the next thing I'll just mention is that if you really want more information on the simulation, there is a white paper. Let's see. Whoops. Can I go to that link? If I control click on it. So yeah, if you follow that link, it'll take you to this page where you can find a white paper that I wrote about it. It's actually easy to find. If you just look SSRN as Social Science Research Network, and then it's certainly the only paper called Churn Sim. So it's easy enough to find. So that just wanted to mention, if you want more really detailed information, that's where you can find it. So now let's say, this is an overview of the simulation. I'm just gonna start talking through some of this. The first thing to note is that there's 2 domains of the simulation. One is the actual simulation, kind of shown here in the top half, and then the other is the database. So it writes to a database, which is what it's doing right now. Speaking of which, I wonder if we can see any action on the database front if we refresh this page. So we're writing the results of the simulation to a database in a realistic looking way. Okay, yeah, so we actually really are putting some load on the database to write all this data in. And so there's actually just 3 tables created by the simulation. You've got your accounts, which is your customers, a subscription table, which tells you what they were signed up for, and then the event table, which has different types of events, summarize their actions. And so this is really what the data you have to work with in a real churn use case looks like. I mean, basically, you got those tables and you got to figure everything out from this raw data, which is very different from a typical academic data science exercise where they give you the data set. What you might be thinking is, where's the data set? Shouldn't I have a data set? And the answer is no, we have to create the data set. That'll come in later streams. Well, let's talk more about the simulation now. The simulation involves customers which use a Poisson distribution to create their action events based on a rate model which determines their rate of activity. And there's a log normal model, which I'm going to talk about in a minute, what that means. So the log normal model gives the customers their behavioral rates. They take these actions and then they choose their product plan based partly on their rate of action. So the people who want to use the product more will switch to a higher action plan. And then the key thing is there's a model for what I call utility in the economic sense, meaning like how much do the customers like or dislike the product. And that is actually what gives them, the customers, their desire to churn or to upgrade or downgrade to different products and plans. So that's kind of the overview. And now I'm going to try to quickly talk through these different parts. Quick, because I don't want to bore people. But I also want to show you the real code. So actually now let's go do that. I'm going to do a quick code download demo. So then we can look at some of the code as I'm going. Let's see. I have my own GitHub repo bookmarked here. So here it is, Carl24K, Fight Churn. And let's see, let's just download a zip. Let's see, and where did I save this? I guess it's in my downloads folder. Let's take a quick look here. Fight Churn Master. Okay, I'm just gonna like put this into a better place. Maybe this churn folder that I have. And to open up the code, I'm actually going to go to my favorite tool for Python code. I'm a PyCharm user. So I'm going to make a new project because I'm showing you I'm just kind of like starting everything from scratch here. Let's find that new code that I downloaded. Let's see. Should be here, Fight Churn Master. Yeah, and I'll just open this project. I'm going to worry about the virtual environment a little bit later, although it looks like it's just like defaulting it reasonably well. So I'm going to do this, create from existing sources. Whoops, it's opening up in a different window here. But here it is. All right, so here we are on the README, and we're not really going to be running any code today, but we are going to look at it. And so all of the stuff we're going to be talking about is in Fight Churn Churn Sim folder, and we're going to look at it in just a moment, but this was basically my reminder to download the code. I also want to keep my simulation up in the back. And actually, it looks like the simulation is completely done. Yep, this is what will happen if you run the simulation. So it ran pretty quick on 16 cores. I guess that was about, what was that, 15 minutes or so, 10 minutes? Let's see, starting at 1907, ending at 1916. So really just 10 minutes. So now you can imagine if you're not using 16 cores in Google Cloud, it will probably take a couple of hours to run this. And that's why, of course, I use like a slightly, decent cloud instance to run it. Okay, so that is done. And now I can go back here to the full screen and just go through some of this. So this is a CRM simulation. And if you're not familiar with what a CRM is, that means a customer relationship management system, which means it's a tool that salespeople use when they're selling stuff. So we're going to look at some of these configurations right now. Actually, let's get back here and go into my Fight Churn Master. So I said we should go into Fight Churn, Churn Sim. There's a configuration directory. And if we look at the CRM 5 plans, I'll just open it up in Excel to make this easy. It's a CSV file. I guess I could open it up in PyCharm too, but it's actually kind of easier to see it in Excel. So these are the plans for the simulation. So this is a SaaS product with a starter, basic, standard, advanced, and premier levels. And each version comes in a monthly, a biannual, and an annual version. They all have different prices, and if you look, these are just kind of whole round numbers. Okay, it's not super realistic in that everything should be ending in like 99, but there's different levels of pricing. And there's different levels of the number of users that you can use for each one of these plans. There's also some other limitations. These are the behaviors that are, we'll say more about these in a minute, because we have to look at what are the actions on the system. But I wanted to start out by just showing the plans. And the next thing we're going to look at is the behaviors, which is in another configuration file. This one says _web. There's actually a few configuration files for behaviors because there are different types of users. So these are web users. And this is what is in the configuration for the behaviors of the simulation. These are all the different behaviors that the users can take on the system. They can do things like search, win an opportunity, which is very important. If you know anything about sales, that's when you actually make your money. The users can give quotes. They can also lose their opportunities, adding contacts and leads. These are all the types of things that people do in a real CRM system, meaning customer relationship management system. This configuration gives you the average and the maximum rate of these actions for the users. And then the rest of this configuration is actually a covariance matrix. We're going to say more about that in a minute, but you can see, if I scroll down, you can see that this is like a whole matrix of the correlation between these behaviors for the users. So really the whole simulation is right here, and it's really amazing that you can, it seems complicated, but you can actually get really detailed interactions through pretty simple behaviors. So those are kind of meant to illustrate the basics of the simulation, like what the users can do and what their different subscription plans can be shown here. And let's talk more about the rest of the simulation. These are the main steps that happen in this simulation. The first one is that there's a log normal distribution, which gives the customers their behavior rates. And then there's, let's just go through it step by step. So what does this mean? A joint log normal distribution. I'm showing a little bit of math here and like kind of a crazy picture, but this in the top left is an equation which gives you the relationship. Omega, this letter here, is the action rates for one customer in the simulation, and they're drawn from this distribution, which is a base number to a power, and in this power, this is actually the normal distribution with the means and covariance that I just showed you in that configuration file. So we draw a behavioral rate for a customer. That means how often the customer will take the actions. And the blue bars here show you the probability of a customer having a given rate of action. And then this curve shows you the action rates. So it gives you a long tail of different customer behaviors. A few customers with low probability will have a very, very high rate of this action. And then a few customers also with low probability will have like a near zero rate. And the largest number of customers will be in this in-between range here. And the reason I use this distribution is because it really matches what real customers in subscription services look like. You've got a few power users who are just plugging away. That's like, this guy up here. And then a few people who are really not using it. That's this unhappy person, And so I found that this gives really realistic looking behavior for the individual customers when you use this form. And we can see this in the code. All right, this is my first prompt to go look at some code, and we can look at this, the code for this. So I'm supposed to go churn sim behavior, generate customer. Here we are back in the project. Let's get into some code. Let's see, churn sim. What was it? Behavior? Yeah, behavior, generate customer. So it's actually in this log normal behavior model, the function generate customer here. We can hide that. And so this is basically the code for that map I just showed you. This is a multivariate normal, and these are the covariance and the means. Actually, you have to take the log of the means to run them in here. What you see in the file configuration is the regular scale version. So you have to put it to log scale, but you make a multivariate normal distribution, and then the customer you draw from the distribution, and then you take the exponential function that I write here. Let's look at that real quick, which is just taking this base to the power. So remember, I showed in the slide that you take a base. This is a configuration parameter, and then x is the power. So that is the exponential function, where this is the code that implements this little bit of math right up here, the log normal relationship. And then I also do put like a threshold of maximums, and there's a little bit of other logic here, but really it's just these two lines is the key to doing the log normal behavioral distribution. And remember, this is giving the customers rates of behavior. Let's go back to the main thing and let me move along. So that's how the generate customer bit works. The next is you take the customer behavior rates and you get random daily behavior. So every customer has a rate that we drew from the distribution, and then the number of actions they take are actually from a Poisson distribution, which is a distribution which represents the expected number of things that happen if you have a certain rate. So it's like you have an average, that's your rate for the Poisson distribution, and it's the probability of having the distribution is the probability of having so many events per day given that average rate. And that's what we're looking at right here. So here it's just saying the number of actions for a customer is equal to just the Poisson, drawing from the Poisson distribution and getting the result with that rate. And this is an illustration of what the Poisson probability distribution looks like for 5, 10, or 20 different actions. And there's a probability of no actions, right? If you have a low rate like 5, there's a decent probability that on any given day you'll take no actions like that. Although if you have a high rate like 20, it gets very unlikely that you're going to have 0 actions on a given day. So let's see, I think we're going to look at some code next. Well, this is actually first some details. The number of actions the customers take is further limited by those plans. Remember, when we looked at the plans, there were some limits. Here, this is actually for the search behavior. Their number of searches is limited to 10, 20, 30, 50, depending on their plan. And actually, all of these plans have a 0 limit on these behaviors. These two actually come from the add-ons. So there's also the users. I mentioned the multiple users. So users are actually drawn in the same way. Let's go back to the behavioral correlation. Somewhere down here is the number of users. So this is actually saying the mean number of users is 10, and the maximum is 100. So when you have multiple users, your actions are multiplied by the users. But the number of users each day is also Poisson distributed. So if the account has 10 users, that's their average number of users, and it may vary from day to day. There's also some logic to boost the rate or reduce the rate of actions depending on if it's a weekday or a weekend. And there's also random event times. And then finally, all of those actions are saved to the database in the actions table. And now we can look at this real quick in the code. In customer generate events. There's customer and generate events. So let's see, scrolling down, it actually gets a little bit more complicated than it sounds. So you have to start by, it allocates some space, and then it's actually doing these for a whole range of dates, actually. That's the other key thing. If you look at this is all the events in a date range. That's what's used by the simulation. So it actually goes on a loop over the days. For each day, there's a day of week multiplier, which is what I was saying about whether it's a weekday or a weekend. Then it gets the number of users each day. So here we're doing the random Poisson draw for the expected number of users to get today's users, or as in a basic simulation, you can just have single user accounts. Then it goes over the each behavior, and this is actually the draw from the Poisson distribution here with the rate for that behavior, and then it gets the new count for the number of events. Then this is the part with the limits. So this is if there are limits due to the plans that the user is on. And then finally, this is the part where it actually turns that into a set of events which are ready to be loaded into the database. So this is, in a quick overview, this is how the daily or the monthly the monthly actions for the user get simulated. And moving right along, we're blazing through this. The next key part is that the behavior of the customer leads to enjoyment or frustration. And I use the economic term utility to kind of describe this. The CRM simulation has utility values for each different behavior, and they're actually stored all in the YAML file. Let's go look at that. We have this, actually the key configuration is the YAML file. And here we'll get that in crm5.yaml. And most of all the scalar configurations and the list configurations are all in the YAML, but I use extra CSV files for those tables of plans and actions, just because I don't really like the table support in YAML. I don't know if anyone knows a better way to store tables in YAML, but I found it not as satisfying as having them in a separate file. But this configuration here is the amount of utility or enjoyment or versus frustration that the customer gets from all the different behaviors. So searching is pretty good, gives them 10 utility points. It's just like a point system. Losing an opportunity actually has this multiplier here, which is for the value of the opportunity, because opportunities mean sales in the CRM lingo. So losing an opportunity means missing a sale, and that's a bad thing. Winning an opportunity should be around here somewhere. Oh yeah, it's up here. So these are all of the configurations for how good or bad the things are when the customers use the system, and that's what makes them enjoy it or not enjoy it. So that is where we get the utility. We set the utility values. And now this is the equation that actually gives you, the customer, their utility. And there's a diminishing return equation here. It's actually like a logarithmic, or it's actually like an exponential growth to a limit, kind of. I think that that's the way to explain this equation. But you've got the total utility shown by this variable. I think that's a new. Someone help me out with the Greek letters, please. Come on, chat. You're all asleep. This variable is the rate. It's actually the average rate for all customers. Oh, there's a question. Hey, thanks, Avery, for actually showing me that the Twitch chat is alive. Is there a reason that losing an opportunity isn't as valuable as winning? Yeah, I set them as different, and a little bit that's a value judgment of the creator, of the system. I mean, people, I figured that in this simulation, people lose a lot of opportunities. They lose, and it's just like the fish that got away aren't as important to you as the ones that you got, because the ones that you get, are the money that you made. And I mean, just think about it. I mean, I don't know. If you make a $10,000 sale, you're like, yes, $10,000. And if you don't make a $10,000 sale, you're not like, damn, I lost $10,000, because you didn't lose $10,000. You kind of didn't make $10,000. So it's more of a frustration, Yeah, I think it makes sense, actually. That's just how people behave. It gives also more reasonable looking results in the simulated behaviors, too. That's another way of looking at it. So this diminishing returns part is an important thing also, because I found this is also present in the first Fighting Churn with Data, that the way people behave when they do a lot of an action in churn is well, you might have seen this before, especially if you looked at the book, and we'll look at it again later. If you do a little bit of an action, your churn rate goes down a lot, but then it plateaus. And after a certain point, it's like an adaptation to a stimuli. The more you do something good, it's just not better and better. So this is basically like the diminishing returns of doing these actions. I don't think I'm explaining it that well, but hey, I'm doing my best. And remember, I had a bad day starting off this stream, so that's my excuse for everything bad that happens after that. And so this equation here, this 1 minus E term, is actually the part that has their number of actions. So as the customer takes more and more actions, they're approaching the limit of the utility contribution for that behavior. And that limit is given by the utility values that we were looking at here. So these are the utility values. And this parameter of the average rate kind of just makes it so that the average user gets the average value that you set in the file. I'm not sure that's explained that well, but I don't want to dwell on this. This is how it works. So some other important details about the utility simulation is that customers also have a random propensity to be satisfied or not satisfied, which makes churn harder to predict and more realistic. Also, there's always a negative coefficient on what you pay, which is known as MRR in subscription lingo. So somewhere in here we should have a coefficient for MRR. So it's minus 0.1 points, minus 0.1 utility per dollar. And you remember, we also had the dollar values that people were paying in here. So every customer is going to get a big negative utility from whatever they're paying. And that's also a key part of the realism of the simulation. So let's see. Now we can look at the utility function. Let's go back to the code. Open this up, find the utility file, and let's see, utility function. Okay, great name, huh? like my brilliant coding name there. So this takes the event counts and also the customer itself and actually implements that equation. So if we stare at this for a while, it should look similar to the equation I was just showing you in the slide deck. This is the 1 minus e term to these contribute ratios are the event counts over the means. So this is what I was showing right up here. The event count over the means, that's those terms. And then this is the 1 minus e term. And then these expected contributions are this first term, but those were calculated in the constructor of that object, so you don't see that part. But so this is the utility contribution for a given set of event counts. Now there's also this other stuff here. There's a little special handling of discounts. That's actually another place where I have sort of unequal utility. Well, the discounting is explained in the book. I don't want to go into details on that, but this is the satisfaction part I was telling you about. Each customer has a propensity to be satisfied, and that will actually either multiply or divide their utility by how satisfiable they are. So that's just like a little wrinkle thrown into the simulation to make it harder to predict when someone's going to churn. And that's also to match reality, because one of the things I found is if you do a very direct simulation of churn based on utility like this, is people become really predictable because they're all just governed by these equations. So I had to throw in a few wrinkles to make people harder to predict in the simulation. Yeah, so I think I mentioned these parts. We looked at the utility function, and finally, there is the probability of churn. That's a key part of the churn simulation, is where's the churn? So this is the churn probability function here. The probability of churn, this is a very common equation if you've done any kind of neural networks using sigmoidal functions, so this is like a sigmoidal function. The churn probability, it's 1 minus 1 over 1 plus e to the minus something. And what's that something? That's the total utility. So the higher the total utility is, the lower the probability of churn. So if you have zero utility, then, I'm staring at the equation, trying to remind myself how, sigmoidal equations work. And actually, I'm like 1 minus. So when you have zero utility, let's try to go through this. Then this term should go to e to the minus. Should be going to the constant actually. And as your utility increases, this term is going to get bigger, and then that will reduce your churn probability. I'm not sure I'm explaining this very well, but yeah, I'm just trying to get through the basics right now. So the parameters here are this offset and a scaling factor, and these were also in the YAML file. So the simulate churn is also in the code. Let's see. Where did it say it was? It's in utility simulate churn. So we've already got utility open. So this is simply if it draws a random number, and if that's less than the churn probability, then the person churns. So this is the churn probability function is right up here. There's this generalized function for transition probabilities, which is going to be this one right here. So this is what I was showing you, 1 over 1 plus e to the etc. And there's also a little clipping here. I didn't mention that in the equation, but I found that sometimes you need to clip that equation or it gets like an underflow or an overflow error. And these are the two parameters, the offset and the scale, which actually come from the YAML. So if we look around in here a little bit more, we should be able to find those probabilities. Maybe it's down at the bottom. Okay, yeah, these are the parameters for the churn probability. Now you might also be wondering, what are these upsell and downsell probabilities? That's actually a little bit more in the details here. So There are upgrades and downgrades in the customer's plan as well, and those follow similar curves shown here. And then they have their own parameters. As you can see, I chose somewhat different offsets, but the same scale for the 3 parameters in this simulation. I'll have to go into how you set those in the future. It was honestly a lot of trial and error. There's also a purely random churn in this simulation I called it acausal churn, because it's churn, without a cause that you can identify. And so, yeah, we're practically done. This is putting it all together, how the simulation works, and this is just a snapshot out of that white paper, which is that for each month, for each customer rather, you pick the number of actions according to the Poisson distribution and add up your actions day by day. Then you calculate the customer's utility for the month. We look at that, and then determine if the customer churns using that last bit that we were looking at. And that's really it. That's the loop of the customer simulation. And then this is the overall churn simulation. How you basically start with n customers in some given month, and you simulate them as long as they last. And then you just go through additional months, and you're going to add new customers each month. And the new customers added are just added, with a simple growth formula. And so this is an overview of the churn, the whole churn simulation algorithm. It's actually, pretty simple actually. Although the details of each customer get a little bit involved with those things like the utility equation and upgrade downgrade. So now we can go back, take a quick look at the overall run simulation. It's pretty much going to look just like what we said. I guess we want to go into this one really. Run simulation here. So this is going to be the algorithm we just looked at. So there's a helper function, create customers for a month, and you call it for the initial month, and then for each following month, you add some customers, and then you call the same function again. And that's the main algorithm. I mean, that's the main loop. This is kind of the equivalent to what I called algorithm 2 here. And then if we go into this one, then there's a helper function to create one customer. And this is basically, create one customer, I guess, is really the algorithm for one customer. This gets into simulating the customer, which is doing the actions and the utility and the churn we talked about, and then it copies each customer so it's ready to go to the database. So that is a quick overview of the code. Okay, wait, I just saw there's another comment. How important do you think environmental factors are in simulating churn behavior? I think a lot of these items are on a customer level, but how important do you think things like global economic factors are? That's a really good question. And they're probably not that important when times are normal, but as soon as the economy changes, it's like a new normal. And the way I would think about a simulation like the one that I'm using right here is it's pretty much for a fixed point in time in the global economic situation, right? So everything that I showed you, all the configurations like in this YAML, like this is the utility value of all these actions, the utility value of losing an opportunity, winning an opportunity, and even the other parameters like the behavioral, the behavior rates and the correlations. If suddenly we go into a recession, all these things are probably going to change. The average rate of behavior will change, the correlation between behaviors will change, and the utility that the customer gets from behaviors will change. Like in a recession, probably the negative nature of paying, MRR, will go up like this. And so you have to think of the simulation like this one as just existing at a fixed point in time. And then it's very speculative, like how exactly would all these parameters change if we went into a new economic situation. Like you could make a distressed economy simulation maybe that would be different from your normal economy simulation. So I don't know if that's really answering the question, but yeah, okay, so you think it makes sense. So yeah, this is pretty much assuming it's all stationary to use in the simulation, to actually use some data science and statistics lingo. There's like a fixed generating process that generates customers and the actions of the customers and the behavior of the customers. Everything's fixed. So it's kind of like assuming that the world is just sort of staying in place. And it's pretty much what we do in all statistics and data science and machine learning. We kind of assume that the world tomorrow is going to be like it's been in the past. And then if it's not, then guess what? Your model is wrong and you have to deal with it. Fit a new model, or, yeah. All right, so we're getting near to the end. I think we've looked at just about everything. There are some of these other miscellaneous configurations are all in here. We don't have to go into these population and country details right now, but there are other miscellaneous configurations. Actually, like I mentioned, the growth rate, the number of initial customers, growth rate, it's all here in this configuration. And that's it for the learning about the simulation. So now let's check out the simulation data. All right, this will be a little bit more of live coding and stuff here. The first thing I need to do is add IP connection for the database from my local. So now what I actually have to do is get my IP address. So I'm going to hit up a what's my IP, because remember how earlier I had to add the connection for my simulator instance to the database. Now I've got to go back. I want to add for my local machine, so that my local machine can query into this database. So let's see, I go back to the networking tab. I'm going to add a network. And this is just going to be my home. I guess if anyone's really watching, they can find out my home IP address there. I don't think that's a big security risk, though, that if someone knows like what my own IP address is. All right, so now that's adding. So I'm actually going to now go into my favorite, or one of my favorite tools, and I need to now add the instance to my tool. So that was actually the last time I was messing around with this. What I need to do is go back and now I added my home IP address to the database. Now I need to give the database IP address to my SQL connection. And that should be it, hopefully. All right, let's see. Am I feeling lucky? Okay, wait, maybe I used the wrong, oh yeah, that's just some warning. Okay, yeah, I'm connected, cool. All right, I should be connected, and I have actually some old SQLs saved here. So I'm not gonna freehand these SQLs, I'll just like go through it real quick. So here I will set the search path for my database. And yeah, first let's just check out some of the data. So remember the tables, you should actually be able to see them here. It actually made a bunch of tables, but many of these are for later use in the book. The tables with data are the account table, the event table, and the subscription table. And the rest of them get filled out later in the book. So let's just start by selecting data from the account table, and we'll see what we have on these customers. All right, so each customer has an ID. Maybe I should have sorted them by their ID, but who cares? They have a channel that they use the product on. There's like 2 different apps and the web. This is actually the same as in the Fighting Churn With Data book simulation. Also, every customer has a date of birth, but since these are now firms, these are companies using the product, we look at that not as their human date of birth, but as like the firm founding date or the age of the firm, which can still play a role in the analysis. And for country, you might look close and notice these are actually states. In the original simulation, I called the field in the database the country. And then in my new simulation, I wanted to make them like states in America. So that's why these, it's called country, but they look like states. But ignore little details like that. I didn't want to go through the complication of renaming the field in the schema from what it had been in the book. Enough said. All right, so let's look at the subscription data. Remember, there were a bunch of different products created there should have been different products in the simulation, and you can see that we do have them. There's an advanced annual plan, advanced biannual plan, advanced monthly plan. Basic monthly is also a popular plan. Oh, and this is one of the add-ons. I didn't really mention the add-ons. I did briefly say there were add-on products. One is to have access to the meeting scheduler. That's another feature of our simulated CRM. And then, let's see, where's the other? Well, there's another add-on in there somewhere. It was the meetings and something else. Oh, search. It's the unlimited search add-on. So there's two add-ons that you can have. And we can look actually at like the price. I think that's a field here. Should be. Yep, so we have different people with the MRR for the plan. You might actually wonder, like, why are the MRRs different? I actually didn't mention there are also discounts. I think those show up in the subscription table. So you can actually see for the different plans, actually some customers are getting a discount, which is why the average prices are not simply what we saw in the earlier, in the configuration file. They should be close though. And what are the other fields in the subscription table? I think we can just click this one to look at some of the raw data. So this is the raw subscription data for a given account. And you can actually, if you look, you'll see these are, they should be co-terminal subscriptions, meaning each user will have multiple months. So this user has the standard monthly and the meetings in 1 month, and then they have it again, month after month until they churn. And this is a standard way to store subscription data. It's actually the best way to store subscription data, where you make a new subscription month after month. The alternative is to modify the end date of the subscription, but it's again, a best practice if you're looking into this is to store co-terminal subscriptions. Okay, so that's some of the subscription data. Lastly, we should look at some of the event data. The thing with the event data, of course, is there's a lot more of it. If I do this count star from event, I actually might be sorry I did it. Okay, there you go. So there's a bunch of events. How many is that? That's thousands, millions, something like 100 million events in the table. And so this is going to give us a count of the events and joining with the event type table so we can see what they are. I'm actually afraid that this query will take a long time. So I'm going to put in a where clause, which will hopefully work. We'll just look at 1 month. 230131. Hopefully this will work and run faster than if I queried the whole table. Okay, so here we go. So in 1 month, what are our events? Oh, something like 2 million searches, or is that 200,000? No, 200,000 searches, a bunch of editing searches, deleting searches, something like 200,001 opportunities. So lots of people are making sales on this platform if you believe this is realistic. There's also people advancing the stage of their opportunities. They're also losing opportunities, disqualifying opportunities, which is different from losing if you're into the sales and CRM world. Disqualifying an opportunity means you no longer believe it's an opportunity for you, even though you didn't lose it to a competitor. So it's kind of just a distinction. Adding contacts, editing contacts. So there's more behaviors here than in the original Fighting Churn with Data Simulation. And like I mentioned, I wanted to keep the number of behaviors to a reasonable level just to keep the size of the data and the time you have to spend, analyzing it to a reasonable level. So yeah, I think that's a quick check of the data. I don't know if anyone else has anything they wanted to look at, but we looked at the accounts, we looked at subscriptions, we queried some events. I guess that's good enough for an overview. And lastly, what do we do when we're done playing around on Google Cloud? If you're doing this as a fun project for yourself, and especially if you got the $300 free credit from Google, don't forget to shut down your instances. So I'm going to do that right now. I'll just exit out of here. And I don't think I really even needed to exit. Just like to get out of everything properly. So I exited my shells. Now I'm going to go back to my VM instance, and I believe I can shut it down from here. And okay, and now to my database. I'm also going to shut this one down with the stop button here. Let's see, is that working? Okay, stopping. All right, if you don't do that, then obviously you're going to keep spending money on Google Cloud when you're not doing anything. So that's just a little reminder for myself not to leave this running until my next stream. I want to remind everyone, if you want, check out the Churn Sim white paper on SSRN. A little bit hard to catch that here. But if you want more details on the simulation, that's where you can find it. And I think that about wraps it up. This is the summary of what I talked about today. Fighting churn is about targeted interventions like product improvements, engagement campaigns with your customers, and also customer success and support functions. The code for the book is all in GitHub at carl24k/fight-churn, and it's based on Postgres and Python. We saw a lot of that. And when you want to learn the techniques in the book, there's a simulation of data using a log normal model for customer average behavior, which we looked at today. Enjoyment and utility are modeled with an equation that has diminishing returns. And there's a sigmoidal relationship where churn decreases with increasing utility for the customer. And what we really looked at today was a brand new simulation. This is like a new and better simulation. When I originally wrote the book, I didn't have, honestly, enough time to make as good a simulation as I liked. And so if you watched my other streams, last year I did a conference, the Open Data Science Conference, and that was when I really tried to make a better simulation. I wanted to do something new for that conference presentation, and if you look at my old streams, you can see I did like a rudimentary version of this simulation, the more advanced simulation, having different plans and prices and things like that. And then it was sort of a labor of love this past year to advance that simulation enough to, really make it full-featured and realistic in a lot more respects. So that's what we saw today. Reminder again, you can get my book, Fighting Churn With Data, at manning.com, and do use the discount code TWITGOLD40, gets you 40% off Fighting Churn With Data at manning.com. And so what's next? Well, first, follow me for updates. Showing here my link tree. I don't know if anyone else is using Linktree now, but with all the social media explosion these days, and Twitter sort of turning into the X, and Mastodon, Threads, so many social networks now. I'm putting myself out there on the Linktree, so you can follow me on the social network of your choice. Today's music brought to you by the Lo-Fi Chill Stream Safe. You can find this on Spotify, so if you're wondering. And thank you for watching. Actually, usually in this part of the stream, I do some thank yous for new followers. Let's see, who has followed me recently? We'll see some of these. Carlos Andres following me. Thank you for following. And next one coming. These always take a while. I want to give people their shout outs. Hey, Avery Bub must have just started following because I didn't trigger that one. Thank you for following, Avery. Hope you enjoyed it. Let's see, other recent followers, if this thing is working. More Research followed me actually 24 days ago. So More Research, if you're out there and you watch this stream, I gave you a shout out. These things take forever to replay. So I'll just do one or two more. I didn't have a good Idris Softmax Deep. Got to give the shout out to Idris for this. And going for some fun usernames. One thingy. Safety Vest 2789 now following. And maybe one more that I don't quite understand, but Jabush DD now following. So thank you all for following me, and thank you also everyone else who followed recently. I won't bore the few remaining viewers with like shout outs for everyone. I will say that you can find the replay of all these videos on YouTube. I do have a YouTube channel if that's your preference. Also, I just leave them up forever on Twitch. So I basically make a highlight from the entire video and leave all my old videos up forever. So you can find them on the Twitch channel too. And if you're watching this on Twitch, you probably know that already. So I don't know why I'm advertising YouTube to you, but if you prefer YouTube, you can find it there too. So I am actually just at the start of a brand new streaming series, which I am calling Fighting Churn with Data Masterclass. I hope that makes it sound impressive and exciting. What we're going to be doing is we're going to be going through the various exercises and learning experiences in the book using the new simulation data. So it should be really fun doing all of the stuff in the book with this more advanced and exciting data set that we just created today. So the next stream is going to be churn rate in SQL. And it's going to be really fun because unlike in the book where I teach different churn rates, but the answers were always the same because it was such a simple simulation. But it's really cool with the new simulation that the churn rates are very realistic and all the different ways of analyzing churn make a lot of sense with the simulated data. I'm probably not going to do the stream for another month though. I think I mentioned at the outset that I'm kind of busy with my day job. So I'm probably going to be aiming for about a monthly streaming cadence. Like I said earlier, I'm not a streaming celebrity or star, but I am a real data scientist who's a leader in data science in my company, and I do live stream too, occasionally. But so hopefully you can join me again for churn rates in SQL. It should be October 21st is what I'm targeting. If there's any change to that, of course, it'll go out on the social media. So yeah, thanks a lot. I don't know if anyone else has any final questions. Been quiet on the chat for a little while, but that's all good. All right, well, this is a good song for my outro. See you all later. Enjoy the rest of your Saturday. I'm gonna get out there, walk my dog, and have some fun outside later today. It's only 1 p.m. for me, so I got the rest of my afternoon ahead of me. Be well, believe in the power of data, and come back and stream with me again sometime. Thank you.